Welcome to Lexopedia. Today we're traveling back in time thousands of years to the cradle of civilization, ancient Mesopotamia, and more specifically to the mighty Babylonian Empire, a civilization that left an indelible mark on the very fabric of our modern world. You see, the Babylonians weren't just building impressive cities and conquering their neighbors. They were laying down the foundation for how we understand the cosmos, how we measure time, how we build structures, and even how we write down our laws. They were astronomers, mathematicians, architects, and legal scholars, all rolled into one fascinating historical package. Over the course of this journey, we'll be excavating the ruins of their civilization, dusting off ancient cuneiform tablets, and piecing together the story of their innovations. From their groundbreaking advancements in mathematics and astronomy to their enduring legal codes and architectural marvels, we'll uncover the Babylonian Empire's lasting legacy. So, buckle up, space cadets. Get ready for a cosmic journey back in time as we explore the Babylonian Empire, a civilization that dared to reach for the stars, and in doing so, shape the very stars we know today. Imagine a world without writing. No books, no tweets, no shopping lists. That was the world before the Babylonians developed cuneiform, one of the earliest known writing systems on Earth. We're talking roughly 3,200 BC, folks. That's older than the pyramids. Now, cuneiform wasn't written with the kind of alphabet we use today. Instead, imagine using a wedge-shaped stylus to press symbols into wet clay tablets. Each symbol represented a syllable or a whole word, and thousands of these symbols were combined to create a complex and sophisticated system of communication. Think about that for a second. These ancient scribes, using nothing but clay and a stylus, were laying the groundwork for recorded history, literature, law, astronomy, and even mathematics. Their writings weren't just messages, they were the blueprints of a civilization. And what stories these tablets tell? We've discovered cuneiform tablets that contain everything from mundane legal contracts and tax records to epic myths and legends that have echoed through the ages. Take the Code of Hammurabi, for example. This collection of laws, inscribed on a massive stone stele, offers a fascinating glimpse into Babylonian society. It covered everything from trade and commerce to family matters and criminal justice, often invoking the concept of an eye for an eye. But it wasn't just legal matters that captivated the Babylonian scribes. They also recorded their observations of the cosmos, meticulously charting the movements of the stars and planets. These astronomical diaries, passed down through generations, would lay the foundation for the scientific study of the heavens. Have you ever gazed up at the night sky and felt a sense of awe and wonder? The Babylonians did more than just gaze. They studied, measured, and mapped the cosmos with a precision that was centuries ahead of its time. Imagine, these were people who didn't have telescopes or computers, yet their understanding of the celestial bodies was astonishing. Using nothing but their keen eyesight and a sophisticated system of mathematics, Babylonian astronomers were able to accurately predict lunar eclipses. They identified the 5 visible planets: Mercury, Venus, Mars, Jupiter, and Saturn, and tracked their movements across the celestial sphere. But perhaps their most significant contribution to astronomy was their development of the zodiac, the band of 12 constellations that lie along the ecliptic, the sun's apparent path across the sky. They divided the ecliptic into 12 equal sections, each named after a nearby constellation, forming the basis of the zodiac we know today. These astronomical observations weren't just for show, folks. The Babylonians used their knowledge of the cosmos to develop a sophisticated calendar system. They understood the concept of a solar year, and they even divided the day into 24 hours, each hour into 60 minutes, and each minute into 60 seconds. Yes, you heard that right. The way we measure time today has its roots in ancient Babylon. We humans have always sought to make sense of time, to measure its passage, to predict its rhythms. The Babylonians, those ancient skywatchers of Mesopotamia, took this quest to a whole new level. They didn't just observe the heavens, they decoded its patterns and used their insights to structure time itself. You see, the Babylonians were mathematically inclined, and they favored a sexagesimal system. That's base 60 for all you non-math geeks out there. Why 60? Well, it has a lot of divisors, which makes for convenient calculations. And as any astronomer will tell you, convenient calculations are a beautiful thing. This base 60 system permeated their understanding of time. They divided the day into 24 hours, each hour into 60 minutes, and each minute into 60 seconds. Sound familiar? That's right, folks, the very framework of our modern timekeeping system is a Babylonian inheritance. Think about that the next time you're watching the seconds tick by on your digital watch. It's a direct lineage to the ancient stargazers of Mesopotamia, a testament to the enduring power of their mathematical ingenuity. Now, you might be thinking, okay, base 60, that's kind of cool, I guess, but let me tell you, this was groundbreaking stuff. Before the Babylonians, civilizations were using less elegant systems, making complex calculations a real pain in the papyrus. But with their base 60 system, the Babylonians could perform sophisticated astronomical calculations, track the movements of celestial bodies with remarkable accuracy, and even predict eclipses. Talk about being ahead of their time. And it's not just about timekeeping. This base 60 system also influenced their understanding of geometry. They were among the first to divide a circle into 360 degrees, a concept we still use today in everything from maps to protractors. So the next time you cut a pie into perfect sixths, or marvel at the intricate workings of a clock, remember the Babylonians. Their legacy lives on in the very fabric of our mathematical and temporal understanding of the universe. Let's talk about law and order, Babylonian style. Hammurabi, the sixth king of Babylon, reigned in the 18th century BCE. He codified laws etched onto a massive stone stele, nearly 300 laws covering property, trade, family, and injury. Surprisingly progressive principles like fitting punishment to the crime. Now, the Code of Hammurabi wasn't just some dusty old relic of a bygone era. It had a profound impact on the development of law, influencing legal systems for centuries to come. Think of it as an early template, a foundation upon which later civilizations would build their own concepts of justice. From the laws of ancient Greece to the legal traditions of the Roman Empire, echoes of Hammurabi's code can be found throughout history. Even today, as we grapple with complex legal questions, the principles enshrined in that ancient stone tablet continue to resonate. The Code of Hammurabi reminds us that the pursuit of justice is a timeless human endeavor. It's a testament to our enduring need for order, for fairness, for a system that protects the rights of individuals and ensures a harmonious society. And who knows, maybe somewhere out there in the vast expanse of the cosmos, other civilizations are grappling with these same fundamental questions, striving to create their own versions of Hammurabi's code, their own blueprints for a just and equitable society. We've explored the Babylonians' fascination with the number 60, their celestial observations, and their pioneering legal code. But their intellectual prowess didn't stop there. Oh no, my friends, these ancient Mesopotamians were also mathematical powerhouses, laying the groundwork for concepts that would shape the very language of mathematics. I'm talking about algebra, that branch of mathematics that uses letters and symbols to represent numbers and quantities. Now, you might shudder at the thought of algebra class, but trust me, the Babylonians were onto something big. They developed sophisticated methods for solving equations, including quadratic equations, which involve unknowns raised to the power of 2. They even dabbled in what we now call geometric algebra, using geometric shapes to represent algebraic expressions. Pretty impressive for a civilization that predates Pythagoras by over 1,000 years. These Babylonian mathematicians were grappling with complex concepts, developing problem-solving techniques that would influence mathematicians for centuries to come. They were pioneers in the truest sense, pushing the boundaries of mathematical understanding and paving the way for future generations of thinkers. The Babylonians' mathematical contributions weren't just some abstract intellectual exercise. Their insights had practical applications, impacting fields like surveying, construction, and astronomy. They used their knowledge of geometry to measure land, design irrigation systems, and construct impressive architectural feats like the legendary Hanging Gardens of Babylon, which we'll delve into later. And let's not forget their contributions to astronomy. The Babylonians were meticulous record keepers, carefully documenting the movements of celestial bodies. They developed sophisticated mathematical models to predict eclipses and track the paths of planets, pushing the boundaries of what was known about the cosmos. So the next time you marvel at a towering skyscraper, use a GPS to navigate, or gaze up at the stars in wonder, remember the Babylonians. Their mathematical legacy is all around us, woven into the very fabric of our modern world. Friends, imagine a world without skyscrapers or suspension bridges. That was the world the Hanging Gardens of Babylon were born into. The exact location of the gardens remains a mystery, but descriptions paint a picture so breathtaking, it captivated imaginations for centuries. Imagine tiered platforms, lush with exotic plants, fed by intricate aqueducts, a feat of engineering unlike anything the world had ever seen, a symbol of human ambition. Overcoming insurmountable challenges, their legacy continues to inspire us, reminding us of limitless imagination. The Hanging Gardens, if they indeed existed as described, were more than just a botanical marvel. They were a symbol of a civilization at its zenith, a civilization that dared to dream big, to push the boundaries of art, science, and architecture. Think about it. To construct such a monument in the middle of a desert required an understanding of hydraulics, engineering, and agriculture that was truly ahead of its time. It speaks to a level of societal organization and cooperation that's truly awe-inspiring. Sadly, like so much of the ancient world, the Hanging Gardens are lost to us, their secrets buried beneath centuries of sand and time. But their story serves as a powerful reminder of the ephemeral nature of even the grandest human creations. Yet even in their absence, the Hanging Gardens continue to tantalize us. They remind us that there are still mysteries to be solved, wonders to be uncovered, and that our understanding of the past is constantly evolving. And who knows, maybe one day the sands will shift again and the Hanging Gardens of Babylon will be revealed once more in all their glory. We often take our number system for granted, but this ease is a relatively recent development in human history. The Babylonians were among the first to embrace the power of place value. Imagine a world where the position of a symbol changes its value. That's the system the Babylonians developed. We inherited this concept, a testament to their legacy. This place value system was a game changer. It allowed them to represent large numbers with ease. This innovation laid the groundwork for centuries of mathematical advancement. Think about it. Without a place value system, even basic arithmetic operations become incredibly complex. Imagine trying to multiply or divide large numbers using only Roman numerals. It would be a logistical nightmare. The Babylonian positional system, however, provided an elegant solution. By assigning different values to symbols based on their position, they unlocked a world of mathematical possibilities. This elegant system allowed for streamlined calculations, making it possible for the Babylonians to delve deeper into the world of mathematics than ever before. They could perform complex calculations with surprising accuracy, a testament to the power of their innovative number system. From tracking the movements of celestial objects to managing their complex society, the Babylonians relied on their positional number system to navigate the world around them. This, my friends, is the beauty of mathematics. It's not just about numbers, it's about the ingenious systems we create to understand and manipulate those numbers. The Babylonian positional number system wasn't just a tool for calculation. It was a testament to human ingenuity, a beacon of intellectual curiosity that continues to illuminate the world of mathematics today. From the heart of ancient Mesopotamia, a tale as old as time itself emerges, the Epic of Gilgamesh. This Babylonian masterpiece explores themes of friendship, loss, and the search for immortality. Gilgamesh, the legendary king of Uruk, embarks on a quest for eternal life. This epic poem offers a glimpse into the Babylonian worldview. The Epic of Gilgamesh is a testament to the power of storytelling. It reminds us that we are united by the common threads of human experience. The influence of the Epic of Gilgamesh extends far beyond ancient Mesopotamia. Its themes and characters have inspired countless works of literature, art, and music. From Homer's Odyssey to modern novels, Gilgamesh's journey shapes our world. This ancient epic inscribed on clay tablets transcends time and connects us across cultures. The story of Gilgamesh, with its themes of friendship, loss, and the search for meaning, resonates today. From the banks of the Euphrates River, the Babylonian Empire rose, leaving a legacy in mathematics, astronomy, law, and literature. As we gaze up at the same night sky, we share a connection with those ancient astronomers. Their insights continue to inspire us today. Thank you for joining me. Please like, share, comment, and subscribe to Lexipedia. Until next time, keep exploring.